There are two possibilities. Either we are alone in the universe or we are not. Both possibilities are equally terrifying. Arthur C. Clarke. There are more stars in the universe or grains of sand on Earth? Actually, it's not hard to answer without hesitation, right? Yes, we know that there are a vast number of stars in the universe. But each grain of sand on Earth is also a substantial figure, isn't it? The famous American astronomer Carl Sagan made this comparison on the television program named Cosmos. According to Sagan, the number of stars in the universe exceeded the total number of sand grains on Earth. Based on the studies of geologists and geographers, it is estimated that there are around 4 sextillion sand grains on Earth. Calculations show that the number of stars in the universe is more than twice the number of sand grains on Earth. When we talk about numbers, our perception becomes blurred after million and billion units. When we start talking about numbers like septillion, octillion, nonillion, our minds get even more confused. Therefore, to understand the vastness of the universe, we will also use visuals and animations along with numbers. This way, we can better comprehend its enormity. We start from a human scale on our planet. We begin our journey from 1 meter away from the Earth's surface. At 100 meters, we can see the Google building. At 10 kilometers, we can see settlements and mountains. At 100 kilometers, we observe the San Francisco Bay. At 1,000 kilometers, Western America. At 10,000 kilometers, we can now see our planet from the outside. At 100,000 kilometers, we see the Earth and the Moon. At 1 million kilometers, we encounter the orbit of the Moon. At 10 million kilometers, we come across asteroids near Earth. At 100 million kilometers, we start seeing the inner planets. At 1 billion kilometers, we observe other planets. At 10 billion kilometers, the Kuiper Belt. At 100 billion kilometers, dwarf planets. At 1 trillion kilometers, we reach the inner parts of the Oort cloud. At a distance of 1 light year, we begin to see its outer parts. When we reach 10 light years, we can now see neighboring stars like Alpha Centauri, Sirius. At a distance of 100 light years, we arrive at a scale called the local group. We pass through the Orion Nebula within the local bubble. At 10,000 light years, the spiral arms of our galaxy start to emerge. At a distance of 100,000 light years, we can now see the Milky Way galaxy. At 1 million light years, neighboring galaxies. At 10 million light years, we are in the local galaxy group that includes some other galaxies. At 100 million light years, the local supercluster. At 1 billion light years, a cosmic web. After this distance, we can no longer see anything beyond the cosmic web. For now, this is the farthest place we can go. A cosmic web containing stars and galaxies in mind-boggling numbers. According to most scientists and prevailing theories, beyond this cosmic web, we are one of countless universes floating in the boundless ocean of the universe. We've traveled quite far, haven't we? Let's head back home then. We have traveled in such a vast universe. But during our journey, we didn't come across any neighboring civilization or living beings. According to statistical calculations, shouldn't there be thousands of millions of habitable environments around us? By the way, where are they? Or in other words, where is everyone? This question is one of the greatest paradoxes in human history and is known as the Fermi paradox. The Fermi paradox refers to the inconsistency between the high probability of the existence of extraterrestrial life and the lack of any evidence or contact to confirm it. Actually, this is a simple question that all of us have asked or could ask. You can hear it from anyone. So even a friend might say, if there are aliens, why aren't they coming? Or why is there no trace of them? However, when this was said by the famous physicist Enrico Fermi, it was considered a paradox. The age of the universe is about 13 billion years, and since the Big Bang, the universe has been expanding rapidly. There are countless stars, planets, and galaxies in the universe. Assuming that Earth is an ordinary planet, the likelihood of other living beings on other planets in the universe is quite high. The real problem is why we cannot prove this, or why we cannot find any evidence. The size and age of the universe suggest the existence of many technologically advanced civilizations. However, this hypothesis is inconsistent due to the lack of observable data to support it. In 1950, while discussing this topic, Enrico Fermi said, "If there are a large number of advanced extraterrestrial civilizations within the Milky Way, why are we not coming across any evidence like alien spacecraft or probes?" The debate started with Michael Hart's article published in 1975, and this paradox is also known as the Fermi-Hart paradox. Another question related to this is the Great Silence. The Great Silence asks, even if space travel is difficult, shouldn't we at least hear radio signals from these civilizations if extraterrestrial life is widespread? By the way, there are also opinions that this paradox does not belong to Fermi, and some even argue that it is not a paradox. Physicists interpret the alleged phrase, "Where is everybody?" that Fermi said to his physicist friends at a lunch in different ways. When it comes to extraterrestrial life, generally two different approaches are encountered. One is the researcher's approach based on the Drake equation, which calculates the number of civilizations in our galaxy capable of detecting signals. The other approach is the Fermi paradox, which considers the research unnecessary, stating that if there were intelligent life, they would have already colonized the galaxy. The Drake equation is an original equation derived by Frank Drake. The Fermi paradox, on the other hand, is said to be a myth, and it is claimed that it was not actually a thought expressed by the physicist Enrico Fermi, after whom it is named. In both cases, let us continue to pursue this question. While we're at it, let's also touch on the Drake equation. The Drake equation is significant in the search for extraterrestrial life. It is an equation used to estimate the number of intelligent civilizations in the Milky Way galaxy. It was first proposed by Frank Drake, who is known for his work in radio astronomy in 1961. Although this equation is known as the Drake equation, scientists like John Leary and Carl Sagan also contributed to the formulation. The equation is as follows. In this equation, it expresses the number of civilizations we might be able to communicate with. The equation takes into account the annual rate of star formation in our galaxy, the number of those stars that have planets, the average number of habitable planets per star with planets, the number of those planets where life could develop in some form, the number of those habitable planets where intelligent life could emerge, the fraction of civilizations that develop a technology that releases detectable signs of their existence into space, and the length of time such civilizations release detectable signals into space. According to the Drake equation, there are an estimated 10,000 intelligent civilizations in our galaxy. In addition to the Drake equation, a scale of potential civilizations was created using the Kardashev scale. The Kardashev scale is a method that measures civilizations based on the amount of energy they could use for communication, according to their technological development. In 1964, Russian astrophysicist Nikolai Kardashev, who was searching for extraterrestrial intelligent life with cosmic signals, proposed the idea that the status of a civilization belonging to a culture primarily depends on two basic things: energy and technology. He based this idea on the fact that a civilization's technical development goes hand in hand with the amount of energy it could utilize and manage. That is, the more energy a society can produce, the more technologically advanced it becomes. Initially, this concept was solely dependent on the energy available for communication. However, it has since been developed and expanded. In other words, according to this theory, a culture's development is, in the broadest sense, a product of energy and technology. Technology enables the acquisition of energy, and social systems, based on this technology, define a culture's status based on the amount of energy used. This scale has a series of different classification levels. Each one is based on a level of energy consumption: Type 1, Type 2, and Type 3. Other astronomers have extended the scale to Type 4 and Type 5. These additions also take into account the amount of energy access corresponding to the amount of information civilizations could develop. In short, in recent years, scientists have extended this scale to hypothetical civilizations, galactic, intergalactic, and multicultural civilizations. Now let's take a quick look at these types of civilizations. Type 0. Planetary culture of the sixth universe. This civilization extracts energy and raw materials from organic-based sources such as wood, coal, and oil. Any rocket used by such a civilization will necessarily rely on a chemical propulsion system. Due to the slowness of this type of travel, a civilization at this level will mostly be limited to its own planet. A Type 1 planetary culture. This civilization will be slightly more advanced than the ones currently present on Earth. They will be able to skillfully utilize all of their planet's energy output. This civilization is thousands of years more advanced than us. Such a society could collect, store, and utilize the energy of their star to meet the energy demands of a growing population. Achieving this status would mean increasing our current energy production by 100,000 times. However, being able to use all the energy of the Earth would also mean having control over all natural forces. This means that humans could control volcanoes, weather, and even earthquakes. While it may be difficult to believe that such capabilities can be attained, compared to the subsequent types, these abilities remain at a simple and primitive level. Type 2 interstellar culture. This civilization can harness the power of all stars. They not only convert starlight into energy, but also control the stars themselves. The most popular method proposed for this scenario is the Dyson sphere. This structure would encompass every centimeter of the star and collect most of its energy output to transfer it for storage on a planet for later use. Alternatively, the fusion power of the star could be used as a large-scale reactor to meet the civilization's needs. Type 3 galactic culture. Traveling from one controlled star to another would contain enough disposable energy to immunize the civilization against extinction. However, this type, having all the knowledge about energy and advancing their civilization to a galactic level, transitions to Type 3 and becomes a main race. This civilization can use the energy output of an entire galaxy. They are approximately 10 billion times more advanced in energy production than a Type 2 civilization and about 1 million years ahead of us. They know how to colonize galaxies and extract energy from hundreds of millions of stars. They can roam in interstellar space and conquer countless planets. For humans, such access means biological and mechanical evolution for hundreds of thousands of years, possibly resulting in a different race than the humans we know. These beings may be cyber or cyborg organisms, living entities that are both biological and robotic. Thus, the descendants of ordinary humans might become a subspecies among highly advanced societies today, and entirely biological humans might be perceived as flawed or unevolved by their cybernetic counterparts. Kardashev, in his own scaling, described beyond Type 3 as it would be far too advanced. However, later, figures such as Mikio Kaku, Robert Zubrin, and Carl Sagan also defined what comes after Type 3. Type 4 universal culture. This civilization would be an intergalactic culture spanning the universe. They could travel through the cosmos, commanding the power of trillions of stars. Such societies would possess superhuman capabilities like altering space-time structures to achieve ultimate immortality, or controlling entropy, perhaps even living within the event horizon of supermassive black holes. For us humans at present, these possibilities seem far beyond our reach. Type 5 multiple culture. This civilization would have opened up its own universe. They would possess the ability to manipulate the scale of the universe, including jumping between various forms of matter across multiple dimensions, encompassing physics and space-time. Such a civilization would host unimaginable powers and abilities. So where does humanity currently stand on these scales? Unfortunately, humanity is not yet at any of these scales. We can roughly say that we are just below Type 0. We still use dead animals and plants as an energy source, still relying on nature for energy. According to Michio Kaku, it would take 100 to 200 years for us to reach Type 1. It is indeed somewhat unsettling that we haven't even reached Type 1 yet. Moreover, the fact that we could easily regress to the Stone Age due to a natural disaster or a catastrophe of our own making is a reality. If we want to go beyond a Type 0 civilization, the first step is to preserve our small universe, end wars, and continue supporting scientific advancements and discoveries. Recapping our knowledge, the observable universe is approximately 90 billion light-years in diameter. There are at least 100 billion galaxies in the universe. Each of these galaxies hosts between 100 billion to 1 trillion stars. There are probably trillions of potentially habitable planets in the universe. In summary, there are many possibilities for life to exist and thrive in the universe, isn't there? So, where is this living life? Or, as we asked at the beginning, where is everyone? If there is extraterrestrial life in other galaxies, it seems like there is no way to reach them. As mentioned at the beginning of the video, I talked about the local group scale while approaching the boundaries of the observable universe. There is a simple reason for why we might never reach anything outside this local group: the expansion of the universe. Even if we were traveling close to the speed of light, it would take billions of years to reach the stars beyond the local group. By the time we exit the local group after leaving Earth, the universe will have expanded so much that it will leave us in an endless journey through the vast empty regions of space. Alright, let's forget about the universe outside the local group. Now let's focus solely on our own Milky Way galaxy. In the Milky Way galaxy, there are approximately 400 billion stars, 20 billion of which are sun-like stars. According to estimates, about 1/5 of these stars host a planet about the size of Earth in the habitable zone. So even if life existed on just 0.1% of these planets, there would be over 1 million life-filled planets in the Milky Way galaxy. However, we haven't found any evidence of life. There is no definite answer to this paradox, but there is a common theory. The Great Filter. Some theorists acknowledge that the absence of evidence proves the non-existence of extraterrestrial life and attempt to explain the reasons behind it. On the other hand, other theorists propose ideas about how the Great Silence can be explained without disregarding the existence of such life. In fact, each of these explanations or hypotheses involves altering the value of one or more factors in the Drake equation. These theories generally do not exclude each other. For instance, the hypothesis that life is rare and the proposition that technologically advanced civilizations tend to self-destruct could both be true simultaneously. According to the Great Filter theory, let's consider our best estimates of the evolutionary path that would lead to a visible explosion in colonizing most of the observable universe. The right star system, something to enable reproduction, simple single-celled life, complex single-celled life, sexual reproduction, multicellular life, large-brained animals using tools, where we are right now, and a colonizing explosion. The Great Silence indicates that one or more of these steps is highly improbable. There is a great filter between simple inanimate matter and bursting life. The majority of matter entering this path fails. In fact, among the billions of trillions of stars in our past universe, nothing has successfully completed this path. The fact that our universe appears to be fundamentally lifeless signifies that the emergence of complex life capable of bursting into permanent life is extremely challenging. Additionally, if there are radically different paths to expansionary permanent life, the filter on our path must be even greater, making the problem even worse. One explanation is that human civilization is unique in the galaxy. In parallel with this idea, many theories have been put forward as to why intelligent life should be quite rare or short-lived. Numerous explanations have been developed under the heading of the Great Filter. Let's take a look at some of these explanations together. No other civilization has emerged. According to those who believe that extraterrestrial life does not exist, the conditions necessary for the development of life, or at least complex life forms, rarely occur. Some even argue that this situation is unique to Earth. This view is called the rare Earth hypothesis. Its proponents reject the principle of mediocrity and propose that Earth is not a typical planet, but rather an exceptional and even unique one, attempting to offer a solution to the Fermi paradox. The idea of an exceptional Earth has received support from philosophical and religious origins in the past, but the rare Earth hypothesis puts forth measurable and statistical arguments that suggest complex life in the universe is quite rare because Earth-like planets are already quite rare, or that an extraordinary series of coincidences allowed for complex life on Earth. Intelligent life self-destructs by nature. Technological civilizations may likely or always self-destruct shortly before or after developing radio or space travel technologies. The cause of extinction could be nuclear warfare, biological warfare, or accidental spread of diseases, nanotechnological devastation, poorly managed physics experiments, poorly programmed artificial superintelligence, or environmental disasters resulting from deterioration of the planet's ecosystem. Intelligent life naturally destroys others. Another possibility is that intelligent species beyond a certain level of technological capacity may choose to destroy other advanced civilizations they encounter. Themes of annihilating all intelligent life in the universe by someone or something have been explored not only in science fiction, but also in scientific literature. They might attempt such destruction due to paranoia driven by expansionist purposes or their inherently aggressive nature. They exist, but we can't find evidence. Even if there are technological extraterrestrial civilizations, humans may not be able to communicate with them due to various filters. Scale or technological issues, attempts by aliens to communicate in ways that we cannot comprehend, or humanity's refusal to acknowledge the existing evidence could be some of the reasons for the lack of communication. Necessary time. Humanity has not been searching for extraterrestrial life for a sufficiently long time. It's possible that humanity hasn't existed long enough to be discovered by others. The ability of humanity to find and communicate with extraterrestrial intelligent life has only been a short period. If the discovery of radio telescopes is considered a milestone in this regard, It has only been available since 1937. Additionally, Homo sapiens is a very recent species on a geological scale. The entire time span of human existence, approximately 200,000 years, is quite short in cosmological terms, and radio broadcasts have only been possible since 1895. Therefore, humanity has neither conducted research for a sufficient time to discover another civilization, nor has it existed for a long enough period to be discovered by other civilizations. All galaxy physical propagation is very expensive. The feasibility and cost of interstellar colonization may not have been fully calculated based on current scientific knowledge. In such an endeavor, theoretical barriers that are not yet understood may emerge later, or the material and energy costs may be so high that no civilization could afford it. Aliens have reached technological singularity. Another possibility is that technological civilizations are invariably in a state of technological singularity and exhibit a post-human character. Such theoretical civilizations would consist of being so vastly changed that human beings would be unable to communicate with them. Communicating with these civilizations beyond the singularity would require much more information exchange over interstellar distances. Perhaps they would find every piece of information we provide so simplistic that they would decide it's not worth communicating with us. This situation could be analogous to humans attempting to communicate with ants. They might prefer to communicate with beings more akin to themselves. Zoo hypothesis. The belief that alien races would want to communicate with the human species could be a fallacy. Even if the aliens have the technical capability to communicate, they might prefer not to communicate with humans. One possible reason for such a preference is called the zoo hypothesis, where Earth is like an isolated zoo or wildlife reserve continuously monitored by extraterrestrial beings. They are not technological. It is not clear whether this intelligent civilization must necessarily be technologically advanced. An alien species may choose not to develop technology due to unsuitable conditions in their environment or for other reasons. In this case, discovering such a civilization would be very challenging for humanity. I saved the best for last. Simulation theory. We might be living in a simulation. If that's the case, other forms of living beings may not have been included in the simulation, or our ability to communicate with them might be restricted. Perhaps intelligent life forms have been included in the simulation, but due to the reasons mentioned earlier, we may still be unable to reach them. In addition to all this, religious and philosophical answers have also been provided on the subject. Certainly, according to many traditional views in the Western world, humanity is the sole intelligent creation of the divine. Those who hold these views naturally reject the idea of intelligent life existing elsewhere. There are also conspiracy theories that suggest extraterrestrial beings are already among us, but choose not to be noticed or are being concealed by governments. In summary, while the possibility of extraterrestrial living or intelligent life may be high, there are equally significant obstacles preventing us from detecting them. Additionally, the fact remains that we might bring about our own downfall by trying to do so. Then one day, perhaps,
we have received your radio signals. We have decided to use your bodies as a power source for our game consoles.
a group of extraterrestrial beings may appear like this. As for me, I am just lonely human. Research will continue, and I'll see you in the next video.